All right, we're back. This is page 45 of math analysis. Note 5, we're graphing trig functions, and what we want to do, we've figured out, I think, how to graph sine and cosine. Now we want to figure out how to graph cosecant and secant. And what we're going to do is we're going to use the idea of reciprocal functions to deal with this. So let's take a look at this and see if we can just graph the reciprocal of a parabola and see what happens. We'll take the ideas we get from that and kind of like generalize them and kind of go from there. So here's what we're going to do. We have the graph of x minus 2 times x plus 1. So that's the graph that's shown below. What we want to do is we want to take it and turn it into, more or less, the graph of 1 over x minus 2 times x plus 1. So the way that I usually do this is I like to start by looking at the zeros of the graph that I'm going to graph the reciprocal of, right? So f of x, x minus 2, x plus 1, the zeros are 2 and negative 1. So what's going to happen is when I take the reciprocal of zeros, you can't divide by 0, so the reciprocal of that is going to be undefined, which means we're going to end up with vertical asymptotes here. So let's dot those in. So those are the zeros of this graph. And it's really important that we identify those first because they're a huge key feature. They're actually maybe the most important feature. So the next thing that I'm going to do is let's try to think. So if we saw anywhere that the graph was equal to 1, that would be awesome because the reciprocal of 1 and the reciprocal of negative 1 are themselves, right? The reciprocal of 1 is 1, the reciprocal of negative 1 is negative 1. So if you look at the graph, you can actually find those points just visually here. So this point is going to not move when I take the reciprocal. It's still going to be there. This point also not going to move, not going to move, and not going to move. So the points where you have 1 and negative 1, they're not going to move. So the next thing I want to think about is, let's see, so we could find the exact value of the vertex of this thing. So the vertex is here. And so let's see, that's at 1/2. And if I plug 1/2 or sub 1/2 in here, I'll get, so f of 1/2 is going to be 1/2 minus 2 is negative 3/2. And then 1/2 here is 3/2. So I'm going to get negative 9/4, so like negative 2.25. The key thing there is the reciprocal of negative 9/4 is negative 4/9, right? So if a number is, if the absolute value of a number is bigger than 1, its reciprocal is smaller. So the reciprocal is negative 4/9, which is like, I don't know, it's like almost negative 1/2. So let's say we just put it kind of there. All right. And we could do this for like every point. We could just keep finding points, keep finding the reciprocals. But that's going to be kind of labor intensive, and we don't really want to do that. So instead, let's think about what happens here. So over here, in this direction, the original graph is just going to keep getting bigger and bigger and bigger, bigger y values, which means that when I take their reciprocals, they will get smaller and smaller, right? The reciprocal of 1 is 1. The reciprocal of 2 is 1/2. The reciprocal of 3 is 1/3. These are getting smaller. The reciprocal of infinity is basically 0. So what's going to happen is the original graph is going up, but this graph, the graph of the reciprocal, is going to do this. Now, what happens on this little interval here? This is a big question that we need to deal with. So this interval here, right? So we are approaching 0 as we move toward 2 from the right. As you approach 2 from the right, the original graph is approaching 0. The reciprocals of those numbers are going to do what, right? So we're approaching 0. So like 1 over 10, 1 over 100, 1 over 1,000, 1 over 1,000,000. Take the reciprocals of those. We get 10, 100, 1,000, 1,000,000. The graph of the reciprocal is going to do this. So this is really interesting because we're starting to get the shape of this graph. Now let's move over here. And I don't know why I'm going from right to left on this, but I seem to be. If we look at this little part right here, well, what happens as we approach 2 from the left, right? From the left. So you're starting at 1 and you're going toward 2. As you approach 2 from the left, the graph of the original approaches 0 again. You can see it, it's approaching 0, but through the negatives, right? So -1/10, -1/100, -1/1000. What are the reciprocals of those numbers doing? Well, they're getting enormous, but negative. So your graph's going to do this. And then what you can start to do is you can start to just kind of fill in the blanks, right? So here, we're just going to connect like this. Here, we're just going to connect like this. Now on this interval from, I guess I can use the same color. As we approach -1 from the right, so as we approach -1 from the right, like start at 0 and move toward -1 from the right, we're again on the original graph approaching 0, but again through the negatives, which means the reciprocals are going to go toward -infinity again. So we do this. This is a big deal. We are going to turn this idea into the graph of cosecant and into the graph of secant. So you got to really understand what's happening here. Now, if we look here, same kind of behavior. So this part, the graph is just going to go up forever. It's going toward infinity, so its reciprocals are going toward 0. So what'll happen is we'll have this kind of behavior. And then finally, there's like one more little segment that we didn't look at. That's here. And we are approaching -1 from the left, right? Start at -2 and go toward -1. You're approaching from the left. You're going to the right, but you're approaching from the left. And the values are going toward 0 on the original graph, but through the positives, which means their reciprocals are going toward infinity. So they will go up like this. And this is a huge idea. So we were able to do a couple of things, right? So we looked at the zeros of the original function. So the zeros of f of x became the vertical asymptotes of g of x. And then points where f of x equaled 1 or -1 didn't move. And then the only other thing we did was we thought about the reciprocals of very large numbers and the reciprocals of very small numbers. The reciprocal of a large number is really small. The reciprocal of a small number is really large. So what we're going to do in the next video is take that idea and turn it into the graph of cosecant, and also fill in a bunch of things using some new notation. So I'll be back in the next video and we will talk about that, and I will see you there.